Hello everyone, my name is Alex Lahovic, and in this video I'll be demonstrating my project called Search Suite++. This assignment focused heavily on OOP designs in C++ and templates, dynamic memory management, and operator overloading, and implementing multiple search algorithms. So before showing you guys my project and how the code looks and how the output looks, I'll be showing you guys my UML design that I've created. So here's my Search Suite UML design. Okay, so as you can see, I have my design right here. So I didn't actually use inheritance in this project, but I used composition. So I actually so I have menu at the top because everything happens because of the menu. So search algorithms actually uses the menu. That's why I have an arrow pointing down. And searchable array and search result both use search algorithms. That's why there's also an arrow pointing down to those two. So let's go into the next slide. So here is on the left a little snippet of the code that I have in one of my files. So I include searchable array.h, searchable algorithms.h, and search results.h in my menu.header file. So I have a class menu, and these are the private variables I have. So I have a searchable array and two booleans here, and in my public I have my menu, my show menu, and my run menu. So basically everything is driven from this point of the project because I have a menu that helps me perform searches itself and uses the other modules over here to actually perform these searches. So that's why I have this UML here. And so the minus is actually, it means that this is a private variable. So I have my those up top, and then the plus means it's public. So let's go into my other one. So here is my searchable array. So I have a template type name T, and my class name is searchable array. And in the private part of my class, I have a T pointer data and a size underscore T and variable. And then I have in my public here some other functions and operators right here. And I have a constructor, a destructor, and an operator for safe indexing, and fill random low high, and sort ascending. And as you can see on the right, I included the table for this as well. So let's get into the next one. So here I have my search result. This is a small but very important class. It encapsulates the result of a search algorithm, which includes the index where the key was found, and then the comparisons of how many comparisons were made. And it also includes a helper method found function and a factory method not found function. So as you can see in the UML right here, I have this class, and then in the public I have the search result, and the search result here int I size underscore T for the template. And over here I have int get index constant and a size underscore T get comparisons constant and a boolean right here. And then again I have this table right here as well. And in my last one, this is the search algorithms module header file. So in this, it contains 4 different template functions: a linear search, a binary search, ternary search and an interpolation search. So these don't actually belong to a class, so they're shown as a module with dependencies pointing outward. So these functions take a searchable array and a key, perform the search, count comparisons, and return a search result. So that's why this is also very important. And over here you could see all of these are public. And yeah, so let's get into the code. So I coded this in Linux. I'll just show you guys a couple of files. So I'll show you guys my header file for the menu, because everything basically drives through this. So in my menu, obviously I included everything, so everything is connected. I used enum options, so it creates readability. So when someone's using this, or if I'm using this code later on and I want to add more things, this is actually a very neat and clean way of doing things. So it uses readability. So yeah, so that's what I have here, and then I'll just show you guys how I actually use this in my menu.cpp. So as you can see in my menu.cpp, I have how my show menu, how it will look. And then I have the is sorted array right here, Boolean. And then I have my void run menu, which I use switch case statements for. So this is how my menu actually works. So let's say you input something, it has to be from 1 through 9 to make sure that it's a valid choice. If not, it'll type invalid choice and please try again, and you'll have to exit the program. If you click exit, you'll exit the program. So here's how I use that enum actually. So instead of case 1, it actually says case generate, and I have it uppercase, so it's just, you could read it well. And then I have case print underscore array, case linear underscore search, binary underscore search, ternary underscore search, and interpolation underscore search, and compare underscore all search, and sort underscore ascending. So what this does is it just kind of makes the code a little cleaner, so you could actually read it instead of just having case 1, case 2, case 3, case 4, case 5, etc. You actually know what it's using. So yeah, so let's actually get into the output of the program now, since I showed you guys that. So we're gonna run it here, give it a second. Okay, so as you can see, I have clean output over here. So it says, please choose one of the following options. So there's 1, you could generate a new array. 2, print array for the first 20 elements. 3, a linear search. 4, a binary search, which is sorted only. 5 is ternary search, which is sorted only. And then 6 is interpolation search. And 7 is compare all algorithms. And 8 is sort current array ascending order. And 9 is to exit. So you could click any one of these. Yeah, so like 9 would exit the program. But let's get back into the program, and I'll show you guys a couple of test cases to show you guys how exactly my code runs and how it works. So first, let's actually generate a new array. So we click choice 1, and then we could enter an array size. So I'll do an array size of 20, and for the range, I'll do 0 to 100, and sort ascending, I'll say yes. So as you can see, the array was actually generated. So this actually shows the demonstration of how the templates, dynamic memory, and the rule of 3 in action are used as it creates that array. So now if you guys want to see this array, you could actually print it. So you could click the second choice and it'll print the array. So as you can see, it has it printed right here in that order. And this output actually uses the overloaded operator for the searchable array, which only prints the first 20 values to keep things clean. So as you can see, it prints all 20 of those. So yeah, so now we could click choice 3. So we could do a linear search, and let's try to search for 33. So if I click that, it'll show that it's found at index 4 with 5 comparisons. So that's working well, as you can see. 1, 2, 3, 4, 5th. So it is at that index. So one of the most important features of this program is actually the 7, which is to compare all of the algorithms. So if I click 7 and I enter the key 33, it'll actually generate everything right here. So let's say for linear, it was found at index 4 with 5 comparisons. For binary, found at index 4 with 2 comparisons. Ternary, found at index 4 with 4 comparisons. And interpolation, found at index 4 with 1 comparison. So what this does is it shows how linear search is order n, it shows how binary and ternary search are order log n, and how interpolation search is very efficient when data is distributed. So this just shows how the algorithm is analyzed, and it matches the sample output that it's meant to match. So yeah, so that's how the project works. So to summarize my search suite project, it demonstrates a clean object-oriented design using the use of templates and 4 searching algorithms, which I just went through, and operator overloading, and how I used my UML design as well over here. So yeah, thank you guys again for watching my demonstration. I hope you guys liked it, and that's the end. Thank you. Have a great day.